Here I am asked to solve for x for both of these equations. And in these equations here, I'm going to use u substitution. The reason that I know that is because really whenever I have three terms that are being added or subtracted together, I should look to see how can I use this to help me factor. It's one of those things about math that we use so often is factoring. And so really like when I set these things equal to 0, and then I have three terms, there's got to be some way that I look for to see if I can factor it. In this case here on the second one, I'm actually going to add 5 to both sides because, again, that gives me just my three terms equal to 0. But each of these problems, I'm going to set something different equal to u. And my recommendation is really what we should be looking for is like something u squared plus something u plus some sort of constant equals 0. In the first one here, the way that that shows up is this 3x minus 2 here in the middle. If you notice, I really want 3x minus 2 to be equal to just one singular letter. So I'm going to say that u in this first problem is equal to 3x minus 2. So when I rewrite that, what you should see is that it kind of helps us out when we try this out. We end up getting x squared because I'm replacing this with, sorry, u squared, my fault. U squared, because I'm replacing this with u, plus 8u, because I'm replacing this with u, plus 12 equals 0. Now I can just factor this using the diamond and box. So if you need practice with the diamond and box, I'd recommend making sure you get that because you're going to need to factor a lot just in pre-calculus and calculus going forward. So make sure you know how this is all done when you're going through these problems. So this factors to u plus 2 times u plus 6 equals 0. I set each of them equal to 0 here, and so I get u equals negative 2 and u equals negative 6. Once I've found what u is equal to, I'm now going to replace back what I started with into u. So what that means is that I'm going to get 3x minus 2 equals negative 2. 3x minus 2 equals negative 6. And now I just have to solve for x. So I add 2 to both sides, divide by 3. My first solution is 0. I add 2 to both sides, I divide by 3, and my second one is negative 4/3. So that's how we use u substitution to help us in the first one. Whereas the second one, I want this same idea where this middle term should end up just becoming u. So the middle term is what's going to help us decide what u is equal to. So what that means is I'm on this one going to set u equal to x to the power of 1/2. Now, the second thing I want to look at is that this first term should be something u squared. So if I look back at this equation, u equals x to the power of 1/2, I'm going to square both sides. And the reason I do that is because now I have u squared, which is what I want to be in my equation. If I square the right side, then this just becomes x. So what you can see here is that I'm going to replace x with u squared. And I'm going to replace x to the power of 1/2 with just u. Now I can factor and solve. So in this one here, when I factor this, I end up getting u minus 3 times u minus 3. I did this all in the same color by accident. That's my fault. But when I solve, I get a single answer where u is equal to positive 3. But I need to solve for x, so I'll go ahead. I know that u, if I go back to what I originally started with up here, u is equal to x to the power of 1/2. So in this case here, x to the power of 1/2 is equal to 3. So I'm going to square both sides and get 9. And so my final solution is x equals 9.